Hello class, today we're going to do a really mean assignment. It's actually called MAD, Mean Absolute Deviation. So our learning target today is to practice finding the mean absolute deviation, or MAD for short, of a data set. So first of all, what does this word mean? Mean. Yes, if you remember what we talked about before, when we find the mean of something, we take all the data that there is, add it together, and then divide by how many there are. Another word for mean is the average. The mean is used to summarize a set of data, and it measures the middle or the average of the data. We've talked about the word absolute before. Remember absolute zero with the two lines coming down? Absolute, how far away it is from zero. It's kind of the same way, but this is called absolute deviation. How far away is the data from the mean? So how far away it's from. So MAD tells us how far on average all the values, so all of our pieces of data, is away from the middle. I would strongly suggest that you pause this, make sure you have a piece of paper and pencil when you do your assignment. There is a little bit of writing. I would allow you to use a calculator too if you needed, but there's some writing that you'll need to do. And I'm going to use the T chart or a T to help with this. The first thing what we want to do is, if my data was 3, 6, 6, 7, 8, 11, 15, and 16, I would want to find the mean of the data. I just like to put it in order. It isn't necessary, but we would add all of our data, count how many pieces there are, which are 8. So I'd add it, 72 is my answer, and then divide it by 8, and that would give me 9. Now on the T-chart, how I would write that is those pieces of data that we had and just have it going straight down. And notice that I put my answer right above the T here. My next step is to find the distance. This is our absolute thing that we're doing here. Find the distance of each value from the mean, and how we do that is we subtract our numbers from our answer that we got. So I'm going to go, how far is 3 away from 9? And we would say 6. How far is 6 away from 9? 3. How far is 6 away from 9? 3. How far is 7 away from 9? 2. How far is 8 away from 9? 1. How far is 11 away from 9? 2. How far is 15 away from 9? 6. And how far is 16 away from 9? 7. Notice I have all new numbers here. And what I'm going to do now is I'm going to ignore my first mean here, and I'm going to work with these numbers here. Remember that I have 8 of them. So I'm going to find the mean of the distances there. So I will add them all up, the 6, the 3, the 3, the 2, the 1, the 2, the 6, and the 7, which would make 30. Divide it by 8, and my answer would be 3.75, or 3 75/100. So what that's saying is the average deviation, or the average numbers that are away from our regular average, with 3.75. And that's how you find the mean deviation. Let's do one more. The following table shows the number of lemons that grew on Mary's lemon tree each season. So we've got winter, they had 3 lemons, spring 15 lemons, summer 21 lemons, and fall 13 lemons. So the first of all, what was our average number of lemons that were grown? So we'll find the mean. How do we do that? We add all 4 of those pieces of data together, which makes 52, and then divide it by 4, which would give us 13. So I put those numbers down. I like to put the 13 on top, and then I can ask my little question. How far is 13 away from 3, or 3 away from 13? That's 10. How far is 15 away from 13? 2. How far is 21 away from 13? That would be 8. And how far is 13 away from 13? That would be 0. Then once again, I'm going to do the mean from the distance, and so I will add the 10, the 2, the 8, and the 0, which gave me 20. There's 4 pieces of data. Divide it by 4, which would give me 5. Hopefully that's enough information to help you get going on this. Let's see how well you do. Good luck.